Oh, hello there, everybody. Today we're going to be talking about complex conjugates and operations with those complex numbers. So we're going to need these complex conjugates to be kind of successful with the overall operations, especially when we're dividing. So let's get into the first part of what a complex conjugate is. We talked already about complex numbers, which if we want to do the general form is a plus bi, which we talked about. This would be considered the real part. And then the bi will be considered the imaginary piece to it. Okay, now here's what the conjugate looks like. Are you ready? It's going to blow your mind. A minus bi. That's it. Okay, that's what the conjugate is. Now, there's a couple ways to visualize it. Now, if I just use, so let's give ourselves a complex number here. Let's say it's just 1 plus 3i. Well, the conjugate to that would be simply 1 minus 3i. Also, we could do, let's say the original complex number was 4 minus 3i. The conjugate would be 4 plus 3i. Okay, now this comes in handy for us when we're dealing with division as our operation especially, and I'll show you that when we start getting to that. But here's our conjugates. Now there's another way to visualize this, and we can use a complex plane, which is the coordinate system for imaginary numbers, or it's also called a Argand diagram, same thing. So instead of having an XY axis, this has a real axis and an imaginary axis. So let's say our original complex number is a plus bi, where our imaginary side, the b value is there, and then our a value for our real number is right there. Now that's the complex number. So if we were to transition that into the conjugate, which we already knew was a minus bi, the b would be down, this would be negative b, which is what that would be. So another way to think about this is that the conjugate is simply just a mirror of the real axis for that. Just another visual. But in general, what we're going to use it is talking about it in terms of being able to simplify effectively using these complex conjugates. Okay, so we'll be able to look at a couple of things. So the first one, before we get into just basic operations with adding and subtracting, there's some interesting things that happen when we do conjugates. So let's use 2 minus 4i. You can write these down as we're going and pause. And let's use the conjugate. Well, the conjugate to 2 minus 4i would be 2 plus 4i. Oops, and I need I'm going to rewrite this because I need an adding piece to it. Plus 2 plus 4i. Now, ideal addition and subtraction of my complex numbers, like combining like terms. So I can do that here with the conjugate and the complex number. So combine my 2's, 2 and 2, that would give me 4. And then the negative 4i and the positive 4i, well, that would just give me 0. Those would go to 0, so I'd be left with this. Now, this is the interesting piece about conjugates when I'm adding them, is that I end up, when I have two complex numbers, where I have its original complex and its conjugate, it gives me a real result, okay, just a real number. Now, that's not the case if I were to do, let's say, 2 minus 4i, there's our first one, and then let's just do plus something different, plus 5i. Now, I won't just get a real result, but I can still do the same process. Combine my like terms. So combine my reals and combine my imaginaries. And then here I'd be able to get my end result. Now, I should be able to, when I combine or have the operations with my complex numbers, I should always be able to get an end result that gives me a plus bi, gets me into this end result, okay, which is here. Okay, now the conjugate does, I just don't have an imaginary piece. So that would be, I guess we could also write that as 4 plus 0i. 0 times that would just give me 0. So it still gives me this end piece, but I wouldn't need to do that for the conjugate. Now, if I subtract, so let's just switch this so it's a subtraction. The only thing I have to pay attention to is that I'm really having to make sure that I distribute this negative to both pieces here. I'm subtracting both of those things. So really this is saying 2 minus 4i minus 3 minus 5i. And then I simply just combine my real and imaginary pieces. And minus 9i. Again, it's still in the form a plus bi. Okay, but that's the basics for adding, subtracting. I don't feel like we need to do more than one example for that each. If you would like to, you can get some practice with it when we have your practice time for that. Okay, but you're just combining your like terms, and then just make sure when you're doing the subtraction that you are subtracting both things, so you're distributing that negative or that minus to both of those second terms. And that's the basics for it. Okay, multiplication. So now let's use the same piece here. So 2 minus 4i. And now instead of adding, let's multiply 3 plus 5i here. Okay, well actually before we start that, so let's hold on that one. Let's do some, instead of doing two of these complex numbers, let's just start with something basic. So let's go 5, let's just go 2 minus I. So still multiplying, but now I'm just dealing with a monomial and a binomial term with my complex. So we'd still deal with this just like we would normally. We distribute. Okay, and we should be able to get an end result. That would get me a plus bi. I distribute, so I'd get 10 minus 5i. Okay, and I can do the same thing. So let's change, but instead of having a real number on the outside, let's have an imaginary. 2 minus I, like that. Well, same thing happens. Distribute. So I get 2i. And then if I do this again, I'd get minus I squared. Well, if we remember from our previous stuff, I squared simply can convert to -1. So if I say minus -1, that'd be the same thing as plus. So this is 2i plus 1. And if I want to write this in my form here, this is really 1 plus 2i. Okay, so I can deal with a single value, whether that's imaginary or real. I would just distribute normally with them and then simplify if I need to, especially if I have multiple imaginary values that I'm multiplying, because then I get a squared. But let's go back to, so I'm going to erase this. Let's go back to now the two, what we kind of consider like a binomial term with our two complex. So I deal with it the same way that I do with binomial numbers, is that I can think of this as a foiling situation, or simply just distributing twice, distributing the 2 and then distributing the -4i, and then I combine the like terms afterwards. So I'm just going to distribute. You can consider it like foiling. So let's do the 2. 2 times 3 gives me 6. 2 times 5i gives me 10i. -4i times 3, -12i. And then finally the last one, -4i. And 5i gives me -20i squared. And remember, the I squared is a -1. So that's really, instead of a -20, it would actually be +20. And here's the thing that kind of follows, is that when I have that, this always becomes a real value, because I'll always end up getting I squared. So just keep that in mind as you're going. So that also gives me an opportunity to still write it as a plus bi. Okay, so now I just combine my like terms, my 20 and my 6. That gives me 26. And then I can combine my imaginaries, which would just give me -2i. And again, I get the form I'm looking for. Okay? So that's the basics for that. So let's try a couple. I'm going to give you a chance here to give some a shot. So I'll put 2 of them out here. Let's go 7 plus 2i, and then -2 plus I. Let's give you that one. And then let's do another one here. Let's go 4 minus 4i, and then 1 minus 3i. So why don't you go ahead, let's combine those. Let's multiply those two complex numbers. Remember, you should get an end result that gets you a plus bi. You should be able to get it in that form at the end with those operations. Give it a shot. Pause the video. Come on back, and we'll get these going. Okay. So let's go ahead and give this a shot. So let's distribute, let's FOIL, however you want to think about it. 7 times negative 2 is negative 14. 7 times I, that's 7i. 2i times negative 2, negative 4i. And then I'm going to shorthand this again. So 2i times I would give me 2i squared, or 2 times negative 1. So that's really negative 2. And then I'll combine. Negative 2 and negative 14 is negative 16. There's my a value. And then 7i and negative 4i would give me plus 3i. There's my complex number after I multiply. Okay, if you got it or you think you're confident, you can skip the next part. Or if you still want to see another one, you can kind of keep holding on here to make sure that you're on the right track. But let's go ahead and distribute this one here again. So I'd get 4. 4 times negative 3i is negative 12i. And then I'd get negative 4i. And at the end here, it'd be negative 4 times negative 3 is positive 12. I squared would change it back to a negative 12 there. Combine your terms, right? Combine your reals, combine your imaginaries, minus 16i. So even these are negatives, these are still in the form a plus bi, where in this case, a is negative 8 and b is just simply negative 16, but it's still in the form we're looking for. All these operations I should be able to get when I'm simplifying or getting to an end result. I should be able to get to a form of a plus bi. Now, something interesting when I'm multiplying the conjugate to the complex. So let's do 2 minus 4i. Ooh, that's ugly. 2 minus 4i. And then let's go to what would be the conjugate plus 4i. Now here's the interesting thing that happens with these complex conjugate. When I have the conjugate, I'm multiplying that to its complex partner here, is that I can still multiply. So I go 4. But now hopefully if you see, if I multiply these 2 times 4, that'll give me 8i. And then negative 4i times 2 gives me minus 8i. This is the part that is nice, is that this goes to 0. So that actually gives me nothing. And then I can multiply the last piece, which would be negative 16i squared, which would actually give me a plus 16. And then if I can combine what's left, which is my reals, I would get 20. So just like the adding, if I multiply a complex and its conjugate, I will get a real result. So that's kind of a unique feature of that when I add and I multiply. And this is the most helpful piece because I'll want to be able to use this kind of knowledge and this property when I am dividing. Okay? So when I divide these, so let's get a set of complex. So 7 plus 2i, and then let's go just 1 minus I. So you see we're dividing. Now again, any operations when I'm combining or multiplying, dividing, adding, subtracting complex numbers, I should be able to get a complex number as a final result. And if you look at this right now, it's a little bit tougher to try and figure out what I would be able to get. But this is where the conjugate works out for me, because if I multiply by the denominator's conjugate, top and bottom, which would be, in this case, if it's 1 minus I, it would be 1 plus I. I can do that because this is simply just a fancy form of 1. So it doesn't change the overall division equation, but it does help me out because now, just like when we had this piece, I'll get a real result on this bottom when I multiply that. Okay, so now I'm dealing with, takes a little bit of a process, but now I'm dealing with basically 2 multiplications. Here, and then 1 minus I, 1 plus I, the conjugate. So now I'm dealing with basically 2 multiplications in the numerator and denominator. Why don't you try, so why don't you pause the video, let's see if you can give me what that end result is going to look like. At least after I factor or FOIL out the numerator and the denominator. See if you can do that. Pause the video, see, and then we'll come back. Okay, so now if I'm going to do the denominator first, because, again, if I go back to this, I should end up with a real result. Okay, so 1 times 1 will give me, I'm going to go down here, 1. And then, again, if I were to do the middle piece, that would cancel out, and then I'll get negative I squared, which would just turn to 1. Okay, 1 plus 1, that'll give me 2. So you see in the end result, I get 2 in the denominator, which is really nice, because now that's a real value. Okay, now let's go to the top piece, and I'll put that here right on the bottom. So if I go 7 times 1, that's 7, plus 7i, I'm going to go a little quicker, plus 2i, and then 2i squared, which will be minus 2. Okay, now if I combine all those, that'll be 5 plus 9i. Okay, now I've ended with a simplified solution because now I'm down with a real value here. Now if I wanted to get it to actually see what, and get it to this, which this actually is, I could also write this as 5 halves plus 9 halves I, and now I'm back to a plus bi. I'm back in that general form. Okay, so that's the basics for division. Why don't I give you one more and let you give that a shot and see. So let's go 2 minus 5i, and then 3 plus 4i. Use that conjugate. See if you can go start to finish and get a end result. If you get to here, that would be just fine, as long as it's simplified. And then, if you want the bonus, go ahead and put it in the form a plus bi. So give that a shot. Go ahead and pause the video, see if you can simplify. We'll come on back. Okay, so let's give ourselves the conjugate, which hopefully if you see it's the denominator. So if it's 3 plus 4i, I need to do 3 minus 4i, top and bottom. Remember, I can do that. It's just a fancy form of 1. And now I have 2 multiplication complex values that I have to deal with. So let's go ahead and do the numerator. Let's do the top. 2 times 3, that'll give me 6. 2 times negative 4i, it's negative 8i, negative 15i. And then at the end here, negative 5 times negative 4 is 20, but I squared will change that back to a negative. Okay, so if I combine all that, that would be negative 20 and 6. That'll give me negative 14, and then minus 23i. Okay, and then the bottom, remember if I do this denominator right, I should get a real result. So I just really have to do the 3 and the 3, which would give me 9, and then 4 times negative 4, which would be negative 16, but because I have that negative 16i squared, be plus 16. So at the end of this, I would get 25. Now I need to look at, now that I'm here, is this all simplified, or can I bring anything down lower? Can I divide anything out? And in this case, I can't. But again, a bonus piece, if you wanted to rewrite this in the term a plus bi, I would simply just put negative 14, oops, let me make this look a little cleaner here, negative 14 over 25, and then that would be minus 23 for 25i. In our cases, and for our intents and purposes, this would be just fine, just as long as these are all simplified. We'd have to look at all that and see. Sometimes this is a better visual to be able to see if everything's simplified, to be able to do that. But both of these are acceptable. Okay? We're going to end there, guys. I'll give you a couple examples. Now, if you want more, I'm going to give you in the kind of the I need help. I'll give some more examples, especially in the multiplication and the division. I'll give you some more example help if you want to see some more. Okay, otherwise that's it for now. Hopefully you guys have a good day, night, morning, whenever you're seeing this. Obviously, if you look at my time, I'm here at night, but hopefully you guys have a good day, and we'll see you in the next video.